Okay, I hope you can see the screen. So good evening one and all. So we'll go with the problem. So first I'll draw the circuit. So I am considering a voltage source. Just a second. Okay. Yes, it is not clear. Okay. So a single voltage source and the remaining are resistors. Let us consider this may be 10 volts. Oh my God. Okay, okay. Let me share the screen. So thank you for reminding me. So I hope you can see the screen now. Okay, so this is a 10 volt source. This may be 3 ohms, this may be 4 ohms, 5 or 6. So randomly I have considered. So this is a single circuit, I mean a simple circuit. So here let us say find the power absorbed by 6 ohm resistor. Okay, so what is the power absorbed by the 6 ohm resistor? Okay, so first of all what we need to do, so we'll change the color. So first of all we need to give the polarities. Okay, so plus and minus, so that it will be easy for us to apply the KVL. Okay, and one more thing, so we need to find the power absorbed by the 6 ohm resistor, and that too we need to apply the KVL. Okay, many techniques are there, so let us apply the KVL and find the solution. Okay, so these are the polarities. And what about this resistor? So since it is linking between the two loops, so for the first loop I can consider the polarities are plus and minus, and for the second loop the polarities will be considered like this. Okay, and so the current direction is considered as I1 and this is I2. Okay, next, so let us go with the solution. So first step is apply KVL at loop 1. Apply KVL at loop 1. Okay, so what is the KVL statement? Algebraic sum of all branch voltages around a closed path in a circuit is always 0 at any instant of time. So algebraic sum of all branch voltages is equal to 0. So here is the branch, so 10 volt source, so write it as 10. Okay, and it is a single voltage source. So since the direction of current is in this way, okay, so it is starting from minus to plus. Okay, if you observe the voltage source here, it is moving from minus polarity to plus polarity. So obviously The polarity here will be plus 10. Next, moving to the next branch. So that is a 3 ohm resistor, right? So again, what is the current direction here? So here we can see that it is moving from plus to minus. So anyhow, it is a passive element, so it will absorb the energy there. So the polarity is minus. So since it is moving from plus to minus. And what is the voltage across the 3 ohm resistor? So basically, what is the voltage across a resistor? I into R, right? So what is the I here? The current flowing through the 3 ohm resistor. So here we have considered the current flowing through the 3 ohm resistor. Since it is in first loop, I can call it as current I1, right? So here I1 into R value. So R in the sense 3 ohms. So it is 3. Just I am using brackets to separate it, okay, for easy identification. Next, why we have to go for voltage here? So since we need to apply KVL, that means algebraic sum of all branch voltages is equal to 0. So this branch voltage is done, that is 10. And what about this resistor? So I into R. So we don't know the value of I1. So sorry, we don't know the value of current. So hence we termed it as I1 into R. So that is 3 ohms. Next, coming for the next branch element, that is 4 ohms, right? So if you observe this polarity, so it is moving from plus to minus. So here I can show you the arrow here. Okay, so plus to minus. Then what will be the polarity here? Minus, right? And what about the voltage across this 4 ohm resistor? So it is again I into R. So but here this resistor is linking between the two loops, right? This resistor is linking the two loops. So we have to go for the difference as per the direction of current. If the directions of current remain same, suppose these two are in this way, I mean flowing in one particular direction, that is I1 and I2, then we can go for addition. Okay, since these two are in opposite direction, we can go for difference. I mean we have to go for the resultant. So that is I1 minus I2 into what is the R value? 4 ohms is equal to 0. So this is as per KVL. So this we have written as per KVL. So further, how we can reduce this equation? So 10 minus 3 into I1. So minus into see again I can write it like this, minus 4 I1 plus 4 I2 is equal to 0. So further I can write this equation as 10 minus 3 I1 minus 4 I1 minus, just a second, so it should be minus here, I have a small mistake. This minus, okay, now it becomes plus 4 into I2 is equal to 0. So let me check once again. So 10 minus 3 I1 minus 4 I1 and sorry 4 I1 minus 4 I2. Next it is, so 10 minus 3 I1 minus 4 I1. So minus into minus plus 4 into I2 is equal to 0. So what will be the resultant here? So minus 7 I1 plus 4 I2 is equal to minus 10. So I want to write this equation in the form of a into x plus b into y equal to c. So let me call it as, it is in the form of, let me change. Okay, it is in the form of a1 into x plus b1 into y equal to c constant. So it is in this form. Okay, so let it be equation 1. Done. Next we'll go with the another loop. So this is for the first loop. So what is the equation? Minus 7 into I1 plus 4 into I2 equal to minus 10. Next, apply KVL at loop 2. Okay, so we'll start with the 5 ohm resistor. Okay, so let us start with the 5 ohm resistor. So as per KVL, so what is the voltage across this 5 ohm resistor? So I into R. So whether it is positive or negative. So since it is moving from plus to minus, so this is the direction of current. So that is I2. So then it becomes minus I into R. So what is the current flowing through this 5 ohm resistor? We can call it, we have termed it as I2. So that is I2 into what is R value? So 5, right? Next, this branch is done. So this is the voltage across this 5 ohm resistor. Next is 6 ohm resistor. Next, minus I2 into 6. Voltage across the 6 ohm resistor, that is I2 into R. R is 6 here. So again it is plus to minus. So the polarity is minus. Next, one more element is left here. So which is linking the second loop, that is the 4 ohm resistor. So this branch is linking with the second loop as well. Okay. So then since we have, see, if you observe this direction of current, so this is the direction of current, right? I mean the path is in this way. So this is the direction of current. Okay, so it is moving from plus to minus. So again it becomes minus. So what is the current? So we have to take the resultant. So that is, I mean the difference, I2 minus I1 into 4. So the value of R is 4 is equal to 0. So this is as per again KVL we have written this equation. So these two are the major steps in this KVL method. Okay, applying KVL for loops. So that is very important. We should not miss the polarity. Okay. So how further this equation can be deduced here? Minus 5 into I2 minus 6 into I2, and again here let me make it as 4I2 minus 4I1 is equal to 0. No? So further I can write it as minus 5I2 minus 6I2. So this is minus 4I2 plus 4I1 is equal to 0. So further, so it becomes minus 4 minus 6 minus 10 minus 15. So it will become 4I1 minus 15 I2 equal to 0. So this will be right for clear. Okay. Again, I'm writing this equation in the form of A2 into X plus B2 into Y equal to C2. So here it is C1. Okay. So it is in this form. Okay, so now we have to solve these two equations 1 and 2. So earlier in the earlier session we have done cross multiplications and we have solved equation 1 and 2, I mean for that particular problem, right? So we have solved this equation 1 and 2 and we have found out the unknowns, that is the current values. Now the same we can use the calculator and we can solve how it works. Okay, now the thing is that we need to find out two unknowns. Okay, so for time being, I can write it as, see, from this a1 equal to minus 7. So have a note somewhere so that I can share you the calculator screen. So you can just dump the values. Okay, and b1 equal to 4. And what about c1? C1 equal to minus 10. And coming to this equation 2. So what are the values of a2? A2 is 4, b2 is minus 15, and c2 equal to 0. Okay, so we need to find out, so two unknowns, that is what is I1 and what is I2. Let us check. Okay, so I request you to use this virtual calculator for time being. So let me share my screen. So just note of these values. I'll stop screen sharing and I'll log in through my mobile. so that you can see the screen. Hope I'm audible to you. Okay. So you can see the screen. Okay. So what are the values there? So we need to find, we need to include A1, A2, A1, B1, C1, and A2, B2, C2. So first of all, what we need to do, uh, see here, mode clear option is there. So you can just click on mode clear, right? Next you can see compound 1, complex 2. Just click on this RCL. So I think you in center like a joystick you can see. So left, bottom, top, right. So you can just click on this right. Okay. So the center button there you can click on right. So there you can see equation, mat, VCT, right? So let us go for 1 equation, right? Next there you can see unknowns 2 and 3. So since our unknowns are 2, okay, so that is so that is X and Y. Okay, so we need to find out the currents I1 and I2. So then click on 2. Okay, already. Okay, so what are the values? Let me check. So here I have given A1 as -7. So click on -7 and type equal to. Next B1 equal to 4. Click on 4 and apply equal to. Next this will be C1. C1 type as -10. Next A2 is 4. Click on 4 and up and click on equal to. Next B2 is -15. So up click on equal to. Next C2 equal to 0. Okay, so the values are, I'll write it here. So I1 is 1.68 amps, and if you click on the equal to, so I2 is 0.449 or 0.44 amps. Okay, I repeat once again. So let me clear everything. Done. So first thing is click on mode clear. So which is on the next button of this on button, right? Next to this on button. Next, click on this mode clear. You can see compound 1 and complex 2. So click on the right option. I mean, in the center joystick type of view is there. So you just click on this right button. Next, go for once again. So here you can see equation, right? So click on 1. So we need to find two unknowns. And then just click on 2. Okay. So why it is not clear? Okay. So once again, so I think this data is saved previously. Okay. So you can retype. I think I need to clear once. Let me turn off and do it once again so that. Hope you can see the calculator. So first thing is to, click on mode clear. So which is next to the on button. So mode clear, right? Next, click on the right button. So which is mention it as RCL, right? Next, once again click on this. Okay, so you can see equation, right? So click on 1. Next, again click on 2. So here you can see A1. So just we need to include the value A1, which is -7. So click on -7 and type equal to, and just click on equal to. Next, B1, the value is 4. Just click on equal to. Next, what is the value of C1? It is -10, and just click on equal to. Next, coming for A2, the value is 4. So click on 4 and again click on equal to. Next, what is B2? It is -15. So again click on equal to. Next, C2 is 0. Okay, so these are the so this is the process, and here you can see X, which is considered as I1. So the value is 1.68, and I2 is 0.44. So this is the process of using the calculator, so to find out the two unknowns. So even in further classes we can go for three unknowns also. Okay, so no need to perform this old technique like cross multiplication, and no need to waste our time there. Just we can use the calculator and solve the unknowns. Okay, so we'll be back to this problem. So this is the value. So I1 is 1.68. So I2 is 0.44. Okay. Now what is the problem they have asked? What they have asked to find out? So find the power absorbed by the 6 ohm resistor. Okay. So power absorbed by the 6 ohm resistor. So what is the power absorbed by resistor? P equal to I square R, or we can use V square by R. So anyhow, we know what is the current flowing through this 6 ohm resistor, which is I2. So hence we can go for this formula. So I square R. So actually it is I2 square into R value. So what is R value there? They have asked for 6 ohms. So we can just write 6. And what is I2 here? 0.44. So it is 0.44 whole square into 6. And what is the value? Let me check. 0.44 into 6 whole square into 6. So that is 1.16 watts. So this is the power absorbed by the 6 ohm resistor. So this is the way of conducting the problem. Okay. So I hope you are clear with this.